Hello everyone. In the previous video, we had discussed about finding the domain of the function.
In that, I had explained about the function should be greater than 0 or less than 0 to find the domain of the functions. Now, let us discuss how to solve those inequalities. If we have some function which is greater than 0 or less than 0 or greater than or equal to 0, let us solve some of the functions. For that, let us assume in these cases a is always less than b. Then the inequalities such as if we have x minus a into x minus b less than 0, that is when the product is negative, then x always lies between open interval a comma b. If the product is positive, then x belongs to other than the interval a comma b, that is from minus infinity to a union b comma infinity. Similarly, if we have the product which is less than or equal to 0, then the same case, but we will get the closed interval because it can be equal to 0. The value will be equal to 0 either at x equal to a or at x equal to b. Therefore, those two points are also included. Similarly, if we have the product greater than or equal to 0, same as the second case, but here we have the closed intervals at a and similarly, for the quotients, there we had discussed about the product. Now let us discuss about the quotients. That is x minus a divided by x minus b is negative. We will get the same solutions as in the form of product because the product will be negative if one term is positive and another term is negative. Similarly, the quotient will also be negative if one term is positive and one term is negative. Therefore, we will get the same solution. Similarly, for the positive value is also the same solution. But if we have it is less than or equal to 0, there comes the difference. Here we have x minus a divided by x minus b which is less than or equal to 0. Now we will not get closed interval a comma b. We have semi-closed semi-open interval because the denominator cannot be equal to 0. X cannot be equal to b. Therefore, we get closed at a, that means x can be equal to a, then the value will be equal to 0, but x cannot be equal to b because denominator cannot be equal to 0. Similarly, for the positive also, that is x minus a divided by x minus b, we will get the same solution, but again a is included and b is excluded. Next, if we have the modulus, I have considered modulus in the numerator. It can be in the numerator as well as in the denominator. So if we have the modulus function in the numerator or denominator, obviously you know that the modulus is always positive. So the value of mod x minus a is always greater than 0. If we have the quotient is negative, then obviously the negative value is the denominator. That is denominator must be negative. Then we get x is less than b. So we got the interval minus infinity comma b. But I have excluded a. Why we have to exclude a? Because if we take x equal to a, then the numerator will become equal to 0. But the case is it is strictly less than 0. Therefore, if we take x equal to a, then we will get the value equal to a. Therefore, we have to exclude that point. Similarly, if we have the positive, if the quotient is positive, then it is b comma infinity. Here we are not excluding anything because in the beginning itself we have taken a is less than b. In the interval b comma infinity we will not get a, so we are not excluding it. But in the interval minus infinity comma b, we had a, so we were excluding that a from that interval. Next, if we have less than or equal to, as I told, it will be equal to 0 when we have x equal to a. Therefore, we are not excluding that point. We'll get all the values from minus infinity comma b. And one more thing, here we have less than or equal to means we are not including b because again it is in the denominator. The denominator cannot be equal to 0. Therefore, it is open interval minus infinity comma b. Similarly, if we have greater than or equal to 0, then the same solution as the second case. There will be no difference. We are not adding anything. We are not deleting anything. We'll just get the denominator is greater than 0. It cannot be equal to 0. Similarly, if we have the modulus in the denominator, same cases will continue, and there is no restriction that in the numerator we have taken in all the cases x minus a by x minus b, and I had mentioned a is less than b. It is not necessary that numerator is less than the denominator. It is just a case which I have taken. If you take in the other way also, the answer will be the same. There will be no difference in the answers. Next, look at some other inequalities. By taking modulus, that is mod x minus a is less than mod x minus b. So it is not in the fraction, or it is not in the quotient form or in the product form. We have taken two inequalities on the either sides. So to solve these type of inequality, we get the values. If we have mod x minus a is less than mod x minus b, then we get x belongs to minus infinity comma a plus b by 2. That is the average of a and b. Similarly, if it is greater than 0, then we get open interval a plus b by 2 comma infinity. And if we have less than or equal to, then obviously we will get the closed interval, and if we have greater than or equal to, then again we will get the closed interval at a plus b by 2. And I hope you all know that we will never use the closed intervals at minus infinity and plus infinity. It is not possible. It should always be open interval at minus infinity as well as open interval at positive infinity. Next, let us consider only one variable. That is, if we have mod x less than a, then x belongs to the open interval minus a comma plus a. Because we know that modulus value always gives the positive sign, positive values. And one more thing, remember, a we are taking a as a positive quantity. Only when a is positive, these are conditions will follow. That is, if we have mod x less than a, then x belongs to the open interval minus a comma a. And if we have mod x greater than a, then excluding this term, other terms will come. That is from minus infinity to a union a comma infinity. Similarly, if we have less than or equal to, if it is equal to a, then minus a and plus a are included. That means we get the closed intervals. And if it is greater than or equal to, again minus a and plus a are included. So we get the closed intervals at minus a and plus a. Similar to that, if we have x square less than or equal to a square, look at the solutions. If we have mod x less than a, the solution was same. If we have x square less than a square also, the solution is same. If it is less than, greater than, less than or equal to, greater than or equal to, for everything, the solution will be same as the before. That is, there is no difference between modulus x and modulus x less than a and x square less than a square. This is because you must know the result, that is root x square is equal to mod x. Therefore, the previous case was the particular case of this condition. If we take root on both sides, then we will go back to the previous solution. Therefore, the answer is almost same for both the conditions. This is all about solving some of the inequalities. So let us continue our discussions in the next video. Thank you.